Hi guys, we're going to go over Chapter 5 for this lecture. Chapter 5 is all about abbreviations and systems of measurement, which you might already be familiar with because some of it has been used a lot in regular everyday life, or if you have kids, you're used to dosing them with antibiotics if they get sick. So, medical abbreviations can be your best friend because they shorten how much you need to write. They can also be your worst enemy because oftentimes they are written and the doctor's writing is sloppy and you can mistake them for something else. So it's always a good idea if you look at an abbreviation that's on a paper and you do not recognize it, or it just looks like it could be something else, to get it clarified with a doctor. And maybe the more often you have to call that doctor, hopefully the neater they'll be so they don't have to keep hearing from you. So there's a big, huge list. Table 5.1 has a list of commonly used abbreviations. And I would say that I see most of these every single day that I work. So look over this list, become familiar with it, and try to memorize it if you can. Don't get stressed out if you can't, because you too, once you start working, will become very familiar with it. So, moving on to the next page, it talks a little bit about ISMP. ISMP is the Institute for Safe Medication Practices, and they monitor and categorize medication errors. They also put out a newsletter, I want to say once a month, and it's really helpful. It talks about common errors that have happened, or maybe some good catches, or things that might not happen all that often but shouldn't be happening at all, whether it's look-alike, sound-alike in a vial, or whether it's an oral syringe that was administered IV. You know, there's a ton of different errors out there that could happen, so it's good to know about them so that you can kind of identify in your own practice how you could stop them. So that covers ISMP. Medication orders contain 6 parts: the date and time the order was taken, the patient's name, medication name, dosage and or amount of medication, the route or manner in which that medication will be administered, and the directions for use. They must be written and signed by a physician. If they are called in as a telephone order, you should read and back and confirm that order, and the physician must sign off on it as soon as they are available to. And different policies apply to different organizations, so it's good to know the policy of your organization. I believe prescription orders outside of a hospital can also contain some other items. They're a little bit more, when it's an actual prescription, sometimes they have the patient address, sometimes they have the address of the clinic, and a few other details, such as refills, because items are never refilled necessarily in a hospital, but they will be refilled in the real world. So, 5.1 continued, figure 5.1 is also helpful. It's another huge chart. These are error-prone abbreviations. As I was saying before, there are great abbreviations, and then there are those that are just going to lead you down the wrong road and probably get you in trouble. Look over this list and make sure you're familiar with ones that we shouldn't be using. If it has a star after it, these are included on the minimum list, meaning they really probably shouldn't be used. Do not use list. So for example, ones that have a star, U or little u for units, we just write out the word units. It's not that long, less likely to get you in trouble, not likely to be mistaken for a 0. Systems of measurement. Before, I swear they talked about this, but maybe they didn't. Let's talk a little bit about leading zeros and trailing zeros. Leading zeros, you always want a 0 in front of a decimal point. That way your 0.7 doesn't get mistaken for a 7. That's a 10-fold overdose, and that is just bad news bears. Same does not apply for after a decimal point. You do not want your 7 to be mistaken as a 7.0 to be a 70. Again, a 10-fold error and walking down the wrong road on that one. So no trailing zeros, but you always want a leading 0. So let's move on to systems of measurement. In order to be able to dispense things, we have to have a system of measurement outside of obviously capsules, counting 1 to 10 or whatever, 30, 90. That's easy enough. But when we're measuring liquids, we need to have a way to communicate how much that person is supposed to get. The oldest system out there was the apothecary system. This was So an apothecary is a druggist or a pharmacist. It's an old-fashioned term. This system is out of date and obsolete. It's no longer used at the present time. The metric system is the preferred system of measurement. It's used commonly across the ocean in Europe and most other places. We do not use it. For some reason we are odd, and we just use the system that the United States uses. I don't know if it has a formal name to it. I forget. But think pounds, feet, miles, ounces. It's the English system of measurement. The household system is the other system of measurement. It's the least accurate, and it's based on teaspoons, tablespoons, etc. We try to stay away from that whenever possible or use conversions. However, it's familiar to people, so sometimes the word teaspoonful is still used. So the metric system is based on liters, meters, and grams. So grams for weight, meters for length, and liters for volume. So something might be dispensed in a half a liter bottle, or maybe the patient gets a kilogram of powder. So there we can start thinking this is how we're going to tell the patient to take it, not necessarily a half a liter. But what you can do is you can make those smaller increments. So the prefix milli means 1,000th of a liter, or yes, of a liter. So a milliliter is really just 1,000th of a liter. So 1,000 milliliters equals 1 liter. A lot of times things are measured in milliliters. For example, 5 milliliters equals a teaspoonful. Grams is the same. 1,000 milligrams equals 1 gram. 1,000 grams equals 1 kilogram. So kilo means 1,000 grams or 1,000 liters, a kiloliter, although you never see kiloliters. That's a lot of liquid. You do see kilograms, you do see grams, and you will see milligrams. So you need to be comfortable converting those. For example, 540 milligrams would be 0.54 grams. So moving on to the household system, we kind of already talked about that. Table 5.3 is helpful for the conversions. 5 mLs is a teaspoonful. If you cook, you might be familiar with these. 15 mLs is a tablespoonful. 30 mLs is 2 tablespoonfuls. It's also known as an ounce. 240 mLs is a cup. 500 is a pint, and 1,000 is a quart. So that covers this chapter. It's short and sweet. Thanks for hanging out with me tonight. It's been a long day. Worked all day, then went to the gym, and then hung out with my boyfriend for a little while before he had to go to work. So if I look tired, it's because I am. But I'm always happy to be able to share my knowledge with you guys. So we'll be moving on to chapter 6 next for this week, and I'll see you guys there.